Warm greetings to all. Myself, Dr. Ratnamala, Assistant Professor in Physics, V.V. Vanniperumal College for Women, Virudhunagar. In this module, let me explain the laws of transverse vibrations of stretched string, also sonometer. First one, laws of transverse vibration of stretched string. Let us consider the string, that is nothing but a wire. Here, the vibrations are produced. It is nothing but a wave. The string is a tight wire. When it is plucked or bowed, the progressive transverse waves move along the wire and it is reflected at both the ends. So here we see that the string gets vibrated, the waves are reflected at both the ends of the wire. The waves superpose with the incident one and produce a stationary wave in the wire or string. Here we see that nodes and antinodes are formed alternatively. Here is the point we get nodes and it is the point we get antinodes. Moreover, the sound produced by the wire or the string has almost the same frequency. The frequency of the wave doesn't change. Let me explain the laws. The first one, law of length. Second case, law of tension. And the third one, law of mass. In the first law, the frequency is inversely proportional to the length of the string, keeping T and mu are kept constants. Whereas in the second law, that is law of tension, the frequency is directly proportional to square root of tension, keeping L and mu kept constant. Whereas in the third law, law of mass, Fs, that is frequency, is inversely proportional to square root of mu. Here we keep L and T constant. First, law of length. Here the tension and linear density of the string are kept constant. The frequency of the vibration is inversely proportional to the length. So therefore we can written as N is proportional to 1 by L. So therefore NL equal to constant. So from this we infer that the frequency of the string is inversely proportional to the length of the string, keeping T and M kept constant. Now comes the second law, law of tension. Here the length and linear density are kept constant. Hence its frequency is directly proportional to square root of tension. This could be written as N is proportional to root T. That is N by root T is equal to constant. So from this we infer that the frequency of the string is proportional to the square root of tension, keeping L and M kept constant. Now comes the third law, yes, law of mass. Here the length and mass are, length and tension are kept constant. Here the frequency is inversely proportional to square root of linear density. That is, we can written it as N is proportional to 1 by root M. Otherwise, N by root M is equal to constant. So from this we infer that keeping L and T kept constant, F is inversely proportional to square root of linear density. Next comes sonometer. It is an instrument used for demonstrating the relation connecting frequency produced by the string when it is plucked, as well as with its tension, length and mass per unit length of the string. Here in this case, the sound produced is a standing wave. Here the standing wave is produced in the string. So this is the diagram which shows the sonometer. Here we see that it consists of the load. The load is hanged to the next end of the string. It constructions behind that sonometer is, it consists of a hollow box of 1 meter long that is used for making the sonometer, and it consists of uniform metallic string attached to it. It consists of a uniform metallic string 1 meter length attached to the wooden board. The first end of the string is connected to the hook, whereas the second end is connected to the weight hanger with the help of a pulley. And the number of string is used is 1, and therefore it is also known as monochord. Here we see that the another end is connected to the load with the help of a pulley. So these are the constructions behind sonometer. Now, in order to increase the tension of the string, weights are added to the second end. Otherwise, we also change the length of the vibrating segment stretched between the two ends. It could be accomplished with the help of adjusting the two knives placed between the stretching wire. Next comes working of sonometer. Here, the standing wave is produced at the edges of the knives with the nodes. Along with the nodes, there is a formation of antinodes. As we have already saw that nodes and antinodes are formed in the wave or string alternatively. Let us consider L be the length of the vibrating element. So we can write L equal to lambda by 2. So therefore the wavelength becomes lambda is equal to 2L. Here F is the frequency of the vibrating element and T is the respective tension created in the string, and mu be the mass per unit length of the string. Then we can write the frequency formula as F is equal to V by lambda. Substituting the values, we get L by 1 by 2L into root of T by mu. Here rho is the density of the material and D is the diameter of the string. Then mass per unit length can be given as mu is equal to area into density. We know the area pi r squared and the density as rho. Substitute these values, we get mu as pi rho d squared by 4. Substitute these values in frequency. So therefore the final result becomes F is equal to 1 by LD into root of T by pi rho. Next comes the uses of sonometer. It is used to find the frequency of the tuning fork, and it is used to find the frequency of AC source, that is alternating current, and it is used to find the tension created in the string. Also it is used to measure the unknown mass hanging down at the another end of the sonometer. I hope all you know some details behind laws of transverse vibration of stretched string as well as sonometer. Thank you.